Hi, ladies and gentlemen, it's Mr. Green. It's Thursday. It's time for Class Connect, and the Class Connect link is missing off the page. It's not there. Well, hopefully you have remembered, and obviously by listening to this, you did remember my announcements that stated I was not going to be in town on Thursday. I'm going to be doing tax testing, and yes, I'm as thrilled about it as you are. But I made this recording in advance so that you could actually get a benefit of Mr. Green's Geometry Class Connect time. Woohoo! Okay, I know, you're all thrilled. Where should you all be? You all should be working on Unit 3. Okay, that's where you should be working right now. Unit 3 deals with dilations. Okay, so that's what we're going to be talking about. Dilations. Wow, what are dilations? Dilations, if you watched my video, you saw it's the eyes. Yes, when you look at someone's eye and you go to the doctor and you got this little pupil sitting here and that little doctor puts a drop in your eye and it gets bigger in the dilated eye. And you have to wear those stupid little sunglasses when you walk outside because now your iris is really big. It's so that he can look in your eye and deep into your brain and see what's going on. No, we're not going to do that. Okay. Sorry. I diverge a little bit. Don't forget, always make quiz corrections if you can, because that'll get your grade up. Just a couple points here and there could make a huge difference. Due dates after 28 days, things start disappearing because they lock down. You'll get permanent zeros. Don't want to see that happening. So, moving forward. Jesse. We know Jesse, don't we? Jesse designs an advertisement on his computer for the school play. We don't have school plays, but I mean, just assume that we did at one of your old brick and mortar schools. The design is 15 centimeters by 20 centimeters. If he uses a scale factor of 4 to enlarge the advertisement for a poster, what will the dimensions of the poster be? Well, you know what? This really is as easy as it sounds. Right now, it's a 20 by 15 poster. Means a rectangle looking like that. And he's going to make it 4 times bigger. That means I'm going to take 15 times 4, and I'm going to get 60. And I'm going to take 20 times 4, and I'm going to get 80. It's going to be a 60 by 80 poster when it gets done. It really was just that simple to multiply those things by 4. Don't look at these as hard problems. These are not intended to be the hard ones. Okay? In terms of scale factor, what distinguishes an expansion from a contraction? Well, a contraction is one of those words like isn't or aren't. Right? No, wait a sec. Wrong type of contraction. Contractions and expansions. If my scale factor is greater than 1, it's an expansion. If it's less than 1, it is a contraction. Okay? Now I'm going to modify this slightly. If my scale factor's absolute value is greater than 1 and my absolute value is less than 1, then we're talking about a contraction. Absolute value greater than 1, then we're talking about expansion. Why? Because negatives are simply telling you where they're located. They move in a different direction. Okay? But it's the size of the absolute value of the scale factor that tells you whether it's an expansion or a contraction. So let's try to look at an example here. It says, let's look at each one of these and classify them as either being an expansion, a contraction, or neither. What would be in neither case, Mr. Green? Well, notice what I've got here. I got greater than and I've got less than. I don't have equal to. So if it equals to 1, it's neither an expansion nor a contraction. It's just a movement. Okay? So a 1 to 64 scale die-cast model of a car. Well, let's see here. The car is going to be the bigger one, and your model is going to be smaller, so this one is going to be a contraction. And notice how it says 1 to 64? That's actually 1 over 64. That's much less than 1. So that one's going to be a contraction. A life-size wax figure of a movie star. Well, if it's life-sized, that means my scale factor is 1. That means it's neither. A souvenir replica of the Statue of Liberty. Well, you know what? I hope you're not bringing home something the size of the Statue of Liberty if you go look at it. I'm hoping this is a contraction. And so what you're looking at there is some scale factor less than 1. A 4-foot by 6-foot poster made from a 4-inch by 6-inch picture. Well, I want you to look at that. It went from 4 inches to 4 foot. It went from 6 inches to 6 foot. Wow. So what they did there was they got bigger. It's an expansion. As a matter of fact, 4 foot's 48 inches. So it went from 40, it went 248 divided by 4, which is where it started. It looked like it went 24 times bigger. So my scale factor is a 24. That's much greater than 1, isn't it? So that would be a expansion for sure. Okay? Interesting. This is on here. Let's see here. 6 times 12 is 72. 72 divided by 6. That's going to be 1 and 2. That's a scale factor of 12. So they're not scaled the same, these two. Interesting question here. Still greater than 1. It's still an expansion, but it's not quite correct. Okay? So, we'll have to look at that one later on. Here, this one's saying the pre-image of PQR. Here it is right here, PQR. That's the pre-image. Under a dilation with a scale factor of 3. 3 means it's going to get bigger. It says the center of the dilation is -5, 2. I want you to notice what it's doing. See, -5, 2 is right here at point C. One way you can do this, draw a point from P through C. It comes down like this. Draw a line from Q through C. It goes out like this. Draw a line from R through C. It goes out like that. What you're looking for at this point is if this is Q and this is P coming down here somewhere. Let's see here. If I'm at 4 and it's going to get 3 times bigger, that'd be 12 something, right? That's not going to work very good. But wait a second. It's at, let's see here. How do I do this? Let's see here. You know, one of the things you could do is you could look at QR. That's a difference of 1. And we know that Q's on this line somewhere, and it's got to be 3 units, 3 times greater. 1, 2, 3. And this one here from Q to P, that's a unit, 2 units. It's got to go from P, it's got to be 6 because it's got to be 3 times bigger. 1, 2, 3, 4, 5, 6. I think we found where the new PQR is going to be located right there. And this is going to be my Q prime, this is going to be my R prime, and this is going to be my P prime. Ta-da! And I did that based upon size. Okay? I looked at the size of this side here and said that one's 2. I had to find one that was 6 over here. And PQ, I had to find a difference where it was 3 over here because that was 1. And that's how you can find those differences. Okay? So, let's move forward here. Here we've got a pre-image is the dashed polygon, and the image is the solid polygon. And they're wanting us to find what the scale factor is here. Well, if you look at this, I'm seeing a 1, 2, 3 is the length on this one, and on the Q prime, looks like it might be, well, I can't really tell, can I? Maybe I can find a side that both of them are on a line where I can count it. 1, 2, 3. And this one looks like it's, well, Still can't really tell all that easily, can I? It looks like it might be 2, but I can't really tell. Let's see here. 1, 2, 3, 4, 4 and a something. It's kind of hard to tell, isn't it? Because it's not really on the lines anywhere, right? It's kind of like it's not a whole number that we could look at real easily. I'm thinking that my scale factor is going to be 2/3. Why? Where did I get the 2/3 from? Well, this one is about 2, and this one is 3 down here, and this one is about 2, and this one is 3 here. Okay? And you know what? We can count the slopes. There, this one goes 1, 2, 1. This one goes 1.5, 1/2. So that does work. You can count the slopes like that if you want to. Okay? As long as you're getting the right information. It looks like it is going to be about 2/3 of the original one. Is it a dilation or is it a contraction? It's a contraction. Okay? It's a contraction of that polygon. Okay. Which one of these are dilations? That means both sets of numbers are going to have to be in the same ratio. So if I'm going from 4 yards to 7/4 yards, and going from 2 yards to 2/3 yards, it looks like I divided by 2 divided by 3. And if I took 4 and I divided it by 3, that's not equal to 7/4, is it? So I would say no, that one is not a dilation. Okay? Let's look at this one. If we go from 1.41 to 2.82, that looks like I'm multiplying it by 2. And then 1.12 times 2 would be 2.24. Looking good. 1.5 times 2 is 3. Yes, it is. All three of them are in the same ratio. This one is a dilation. Okay? Can you see how I looked at the length of the sides to get to that point? Okay. Now, here I've got two trapezoids, and they're saying they're similar. Similar is this symbol right here. It means that they are in ratio to each other. It means that the sides are in ratio and the angles are going to be the same. Notice how I've got this angle right here is 88. Okay, we've got a common angle here, 88 degrees. Okay, and they're asking what's the measure of angle H? H is this angle right up here, and it would be the same as this angle. We don't know what that angle is. Oh, but we do know that in a trapezoid like this, all the angles are going to add up to 360 degrees. These two add up to 180. 280, that's 3. That means this one is a 60-degree angle. That means this one is going to be a 60-degree angle. Okay? And then they ask, what's the measure of side HE and EF? And you notice HE and EF both have G's in them. But that's going to be hard to do, isn't it? Not really. You can say 15 over G is equal to 36 over 3G minus 3. Means and extremes. Deet, 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 deet. And I get 36G is equal to 15 times 3 is 45. G, 15 times minus 3 is 45. Minus 45. Well, I'm going to subtract the 36 G's from this side and from here. And I'll get 9 G's. And I'm going to add the 45 to both sides, and I'll get 45 is equal to 9 G's. Divide by 9. G is equal to 5. So I found HE, that's 5. EF, that's going to be 3 times 5 is 15 minus 3 is 12. Woohoo. Answered that one real easily. Okay? Jacob is building a scale model. Usually means it's going to be smaller, of an apartment building. Each face of the model will be similar to the wall of the actual building. He's using a scale of 1 to 100. That means 1 over 100. The building is 240 feet tall. How tall will his model be? 1 to 100. X over 240. How did I get that? This is the smaller one. This is the bigger one. X over 240. 240 is the size of the tall building. X is going to be smaller. Means in extremes. 100. X equals 240. Divide by 100. X is going to be equal to 2.40 feet. 2.4 feet. Remember, 0.4 is not the same as 4 inches. 0.4 times 12 would be 48. 4.8 inches. So this would be 2 feet, 4.8 inches. Okay? Cool. Okay. Secret word for today is eyes. EYES. So if you're watching this recording, and you better be watching the recording because, quite honestly, I'm not in Class Connect. So if you're watching this recording, make certain you send me that in a K-mail saying that you watched the recording and you're in geometry and your section number is whatever your section number is, and the secret word is eyes. And I will give you credit for having watched the recording. Thank you for your time, and I'll talk to you next time. Bye.